everyone. Welcome to part 5 of the physiology series. So today we are going to complete the renal system. So until yesterday we had completed till here: oncotic pressure, hydrostatic pressure, filtration pressure. Today we'll be starting with filtration barrier. What is the filtration barrier? That is what we need to know. See, what happens is that when there is blood that is flowing, and then it comes into these fenestrations. This is the Bowman's capsule and this is the PCT. All the blood that flows does not get filtered into the Bowman's capsule. There are many things that stay behind and then return from the efferent limb, right? So there must be a barrier that is actually preventing few things from coming outside and keeps it inside. So that barrier is known as the filtration barrier. We need to understand that today. So the filtration barrier is actually made up of three things. The first one is endothelial cells of glomerular capillaries. So the capillaries, their endothelial cells will be there, which forms the first layer. The question comes that all of these are layers of the filtration barrier except, and these three options will be there and the fourth option will be there, right? So we need to actually rule out. So what happens is there are pores and there are fenestrations. This is the endothelial cells of glomerular capillaries. So glomerulus is giving rise to the first layer. Now the second layer. Second layer is the capillary basement membrane. Capillary basement membrane. So this glomerular capillaries. So the second layer is also formed by the glomerulus. Do you understand what I'm saying? The first and the second layer is being formed by the glomerulus. First layer is the endothelial cell. Second layer is the basement membrane. Now the basement membrane again has three layers. This has been asked. That is why I'm mentioning it here. So there are three layers: the inner layer, the middle layer, and the outer layer. The inner layer is known as rara interna. Lamina rara interna. Just a second. Lamina rara interna. The middle layer is a thick layer and it is known as densa, lamina densa. And the outer layer is known as lamina rara externa. This I have never studied during my preparation for NEET PG, but here we are, and this has been asked. That is why I'm mentioning it over here. So the capillary basement membrane again has three layers. Inner layer is a thin layer, middle layer and outer layer are thick layers, right? Now this was the second one. These have negatively charged, this is what we need to know here, these have negatively charged glycoproteins. I hope we understand. So the endothelial cells do not have the negatively charged glycoprotein. The repulsion, negative repulsion comes from which layer? The capillary basement membrane. Now let's come to the third layer. The third layer is known as podocytes. So the podocytes are what? Podocytes are the epithelial cells of Bowman's capsule. So can you understand what I'm telling right now? The first and second layer are derivative of the glomerulus. Third layer is the derivative of the Bowman's capsule. These cells are epithelial cells. These have foot processes. These foot processes are also known as podocytes. That is why they have foot processes. That is why these cells are known as podocytes. And these foot processes are like this. See, this is the cell. And then these are the small projections, feet-like projections. That is why foot process or podocyte. So the place that stays between these are known as slits, fenestration slits. From here the actual ultrafiltration actually occur, right? So these are also known as pedicles. These foot processes are also known as pedicles. These forms the filtration slits or the fenestration. Filtration slits. So 3 layers we know, each of their function we've understood. First one is the endothelial cells of glomerular capillaries, then the capillary basement membrane, and the third layer is the podocytes, which is the epithelial cells of Bowman's capsule. Now, what are the factors that affect the permeability? 2 things: size, charge. Very simple to understand. 2 things. What are these factors affecting permeability? Size, charge. Size. There can be categories of size, right? So it is less than 7,000 Dalton, between 7 to 70,000 Dalton, and then there is more than 70,000 Dalton. I hope this makes sense. Less than 7,000 Dalton mostly are freely filtered. 7 to 70,000 Dalton, these are filtered in minute quantities. Minute quantities. And more than 70,000 Dalton are not filtered. So why is this fact important? Because our albumin, which is our major protein, is 69,000 Dalton, which means it is in this range but very, very close to this one. So this actually is excreted in minute quantities. So when it is in minute quantities, it is normal. But whenever its quantity increases, we call it as albuminuria or proteinuria, which actually suggests that the kidney is going into failure. Why? Because the permeability is altered. So the filtration function of kidney is actually getting altered, right? This was about the size. Now let's talk about the charge. So the charge is that I told you that in the second layer there is glycoprotein, negatively charged glycoprotein. This negatively charged glycoprotein actually repels the negative charge. So anything that is negatively charged will be less readily filtered as compared to anything that is positively charged. So positively charged are readily filtered, like sodium, potassium, magnesium, calcium, and other things. All of them which have positive charge. All of them which have negative charge, it again depends on the size. If it is a smaller size, then it will be filtered, but not as readily as positively charged ones are getting filtered, right? So this was about factors affecting permeability. Now let's talk about the loop of Henle. Important topic for exam. Loop of Henle. What is the function of loop of Henle? Nothing except concentration of urine. Yeah. So the function of loop of Henle is to only concentrate urine. See, what happens is, this is the PCT, this is the loop of Henle, thick ascending limb, then this is the DCT. Almost 75% of all absorption, sodium, potassium, water, etc., everything gets absorbed in the PCT. The rest is going to be absorbed in DCT and collecting duct. What does loop of Henle has to do? Loop of Henle only has to concentrate the urine. How does it concentrate urine? Please understand, very, very, very important. What happens is, in the first part of loop of Henle, there is water reabsorption. There is water reabsorption, okay? Why? Because it is permeable to water. Now what happens when there is so much of water reabsorption? See, there was urine. There was urine. This urine had water. This urine has sodium. This urine had chloride. This urine had potassium. This urine had some proteins. This urine had some other things like, what do we say? Calcium, of course. Then it had H plus ions. It had bicarb, HCO3 minus. So many things this urine had. Now what happened is that out of all of this, this part of the loop of Henle picked up water. Just imagine now water is gone. So if water is gone, first of all, the volume of urine is going to reduce. And second of all, the concentration of urine is going to increase. Why? Because water has been removed. So what is left? Lot of sodium, potassium, calcium chloride, bicarb, potassium, H plus protein. So many things have been left back and water is out. So the volume of urine has become so much, but the content is still the same, minus water, right? So what happens when it reaches the tip of the loop of Henle? This is at its highest concentration. So now body realizes, oh, I am going to excrete so much of things in urine. No, this cannot happen. So while the urine is ascending up, a lot of things again get reabsorbed from the urine. Whatever the body feels is important for us, and we cannot let it go in the urine, right? Most of it is sodium. So what happens in the first half of the loop of Henle? All of the water is reabsorbed. So the concentration of urine becomes very, very, very concentrated. So in the second half, that is the ascending limb of loop of Henle, now body says that we do not want water. We do not want water. Now give us all the ions that we actually need. So sodium, it will take away sodium. It will take away chloride. This is the most important. Now when urine comes here, what is going to happen? Now imagine that this urine, first it had both water and salt. Then what we did, while we were going here, we took away all the water. Then while we were ascending up, we took away all the salt. So what is left inside the urine now? Absolutely nothing. What is there? Very, very, very small parts of water which might have been left back. Very small parts of sodium, very small parts of chloride, and some other ions. This is the perfect urine. This is what we can let go outside the body. Okay, now you can go. I have taken everything that I needed in my body. Water, sodium, chloride, calcium, all the other things that I ever wanted. Now whatever is left with you, you can take back. And what is left with it? Absolutely nothing. Very less things, right? That is why, if you know, like I told you the other day also, that almost 120 ml per minute is the actual filtration flow, right? Like, I mean the filtration fraction. But still, when it comes down, in a day, there is almost 2 to 3 liters of urine is being formed, not more. Never more than this. Why? Because when 100% is being filtered, out of that 99.9% is getting reabsorbed. This is the actual reabsorption that is occurring in the loop of Henle, right? So now I'm going to explain it again. I'll show you the medulla and everything, right? So see, just understand. I might be able to draw. See, doesn't even look like a kidney. Wait. Now it does. This is the cortex. This is the medulla. Just imagine. Everything is about imagination right now. In cortex, what is going to be there? Please imagine. It is going to be like, do I make it larger? Wait, I'll make it larger. Wait, I'll make it larger. Let's be able to understand it today, right? This is the kidney. Wow. Okay. This is the cortex. This is the medulla. This is the cortex. This is the medulla. Now, what is happening is, this is my imagination. I do not know. Like, I might be true, right? I might be correct. This is the Bowman's capsule. This is the PCT. This is the loop of Henle. This is the DCT. And then this is the collecting duct, which comes out like this. DCT. And then this is going to be the collecting duct, which takes from other also. See, I'll make another one, right? This is the collecting. Guys, this is the collecting duct here. This is a nephron. This is the Bowman's capsule. This is the proximal convoluted tubule. This is the loop of Henle. This is the DCT, and this comes down to the collecting duct. The loop of Henle, DCT, the collecting duct. Then collecting duct goes down. Another one over here I'll make. This is the Bowman's capsule. This is the PCT. This is the loop of Henle, which is smaller over here. This is the DCT, which enters into the collecting duct. This collecting duct comes from here. All the collecting ducts join together from everywhere and forms the calyx, and from here urine comes outside. Are you able to understand this part over here? I do not know how I've made it, but I really want everyone to be able to understand here. So can you see that this nephron, this one, this is nephron number 1, this is nephron number 2, this is nephron number 3. Can you see that what is the difference between 2 and 3? Can you see that the loop of Henle in 2 is going up till the medulla, and in 3 it is not going up to the medulla, it is in the cortex only, right? So those nephrons whose loop of Henle goes up till the medulla are known as medullary nephrons. Medullary nephrons. And which are not going and are staying up to the cortex are known as the cortical nephrons. So most of the nephrons are actually cortical nephrons, very few are the medullary nephrons, right? Now what I'm going to tell you here is very crazy. I do not know how I'll be able to explain this. Is slightly difficult. Let's try. Which color? This one. Let's take. So here somewhere, make it like this. The osmolarity is somewhere around 300 milliosmoles. Where do I draw? 300 milliosmoles. Right? Then I come down to the medullary, cortico-medullary junction. Here somewhere it comes down to 400 milliosmoles. Then coming more down, it comes down to 600. Then it comes down to 900. And then at the tip of the medullary neuron, see, this is the medullary nephron. And the tip of the medullary nephron, the osmolarity is 1200 milliosmol per liter. ठीक है ना? Per. So yeah. So this is about it. Did you understand? I'm going to make just I'm going to take this nephron number 2 and into a different slide now. So see, what is happening is, this is the PCT, loop of Henle, DCT, collecting duct. See, is it like this? Yeah. So somewhere here the osmolarity was 300, 400, 600, 900, 1200. Right? Please understand, this is the loop of Henle, right? So the loop of Henle, yeah. So the loop of Henle is the descending limb and the ascending limb, right? Please understand, the descending limb is highly permeable to water. Why? Because it has channels. Which channels are there? Aquaporin channels, right? So what is going to happen? I'll make it again here. See, this is the loop of Henle. Right, you understood the osmolarity. Now just understand here what channels are there. These are aquaporin channels. Aquaporin channels are going to take back all the water from the urine. This was our urine. All the water comes back. Where is it coming back? Please understand, this is going out from the body. It is going out. So whenever I say we are taking it back, taking it in, we are taking it in the interstitium, right? We are taking it in the medulla. We are taking it in the medullary interstitium. Please understand, urine which has gone from the tubule, we have taken water from it. Right now that water is in the medullary interstitium. It has not reached the body. Now it will go into the body via vasa recta. Now this whole water is going to be collected by the vasa recta, and this vasa recta is going to take it into the body. Right now it is in the medullary interstitium, right? So what happens is, as the osmolarity increases, just imagine here at the tip the osmolarity is 1200 milliosmoles, which means outside the tubule the osmolarity is very high, hypertonic. And whenever there is hypertonic versus hypotonic, what the nature tries to equate it. So what will happen? Water is going to move from hypo to hypertonic. So all the water comes out. Now what is remaining in the urine? In the urine, now there is sodium, there is chloride, there is potassium, there is magnesium, there is calcium, but there is very less water. So the volume of urine has drastically reduced. Now what happens in the ascending limb of loop of Henle? This ascending limb is impermeable to water. It is impermeable to water. So now, will the body be able to reabsorb water from here? Huge no. So what is going to get reabsorbed? Mostly sodium and chloride. So now, urine had so many things earlier. It had water, it had sodium, it had chloride, potassium, calcium, and many other things, and waste products. Now what happens is, water we have taken. Now we have also taken NaCl. Now whatever less is left, that is going to reach the DCT and collecting duct. From there, how absorption occurs, that I've explained in I think the first lecture. How calcium, how other things, ADH, under the influence ADH, how water gets reabsorbed, that is what I've already told you, right? So see, now this is the ascending limb. Now there is thick ascending limb here. The thin ascending limb has sodium, potassium, 2 chloride. Sodium, potassium, 2 chloride. This is the symporter that we have, which absorbs lot and lot of sodium, potassium and chloride. Now, whenever we are taking furosemide or any loop diuretic for that fact, these furosemide or loop diuretic are going to come and inhibit this. So what happens is any amount of sodium, potassium and chloride that could have been absorbed by this symporter doesn't get absorbed. That is why there is increased urine output, and that is how body fluid volume is reduced, and that is how it works as an antihypertensive. Right? So this is the diuretic over there. So I hope I was able to make you understand this much part. It is very important. It is mostly based on imagination. So this was all. Now there is one topic left, counter current exchanger and multiplier, that I'll be taking up someday else. Today was only about the loop of Henle. I only wanted to explain how the absorption is occurring and how it is concentrating the urine. This was my focus for today. So I think I've done that. So yeah, we'll meet in the next class maybe. If this is the 5th class, I cannot clearly recall. If this is the 5th class, then I'll be starting with micro or pathology tomorrow. So we'll be doing that. So that is all for today. Thank you, and please keep watching.